So today's lesson is going to be solving log equations. So let me open up our log and exponent note sheet that we've been working on. And we were solving some of these log equations in our last class. And we're going to kind of expand that to include some of these properties that we have talked about where we are expanding and condensing. So we're kind of going to be wrapping together the rules of condensing and expanding with the solving that we have already done. All right, so let's start a new section in our notes here. So we're going to solve a log equation. All right, so here would be one example. If we had log base x plus 6 of the 2x squared minus 9 is equal to 2. All right, now to solve this, it doesn't require anything new for us to do, but it's harder. It just has some different properties to it. So what we're going to do is put this into exponential form. That will move over, and that will move up. And so we would write this in exponential form as 2x squared minus 9 is equal to x plus 6 quantity squared. And now it's just an algebra 2 type of problem where we're going to FOIL out the right side, get everything on one side, and then solve that for x. All right, so let's solve this guy. Sounded like you guys were discussing. Maybe we got somewhere. We've got 2x squared minus 9 is equal to, FOILing the right side gives us x squared plus 12x plus 36. All right, so I'm going to move everything to the left. So 2x squared minus x squared is going to give us x squared minus 12x and minus 45 is equal to 0, right? So far, so good. All right, so now you could factor it. You could use the quadratic formula. I think this does factor into x minus 15 times x plus 3. And so we get two solutions. X is equal to 15 or negative 3. All right, we do okay? Excellent. All right, let's do another example. Let's say we had 3 natural logs, so ln, of 4x plus 8 minus 13 is equal to negative 22. All right, well, we're going to solve this. We want to get this stuff by itself. You got to get the log part by itself first. So using just our regular algebra, we'll move the negative 13 over. So we add 13 to both sides. So we have 3 natural log of 4x plus 8 is equal to negative 9. Okay, I added negative 22 plus 13. I'm going to divide by 3. So I have the natural log of 4x plus 8 is equal to negative 3. So now I have the log part by itself. So I want to write it in exponential form. Well, remember, natural log means log base e, right? So there's like an imaginary e there. The e is going to move over and the -3 is going to move up. And so that in exponential form would be 4x plus 8 is equal to e to the -3rd. So to solve that for x, I subtract 8 and divide by 4. I'm going to write my answer in terms of e. So x would be e to the -3rd minus 8 divided by 4. That would be an exact answer. You could plug that into your calculator and get an approximate answer for that. But if you wanted it exactly, it would be in terms of e. All right. Any questions before I move on to another example? Okay. So our next and last example for these is going to be log base 3 of 4x squared minus 4 minus log base 3 of x plus 1 is equal to 0. All right, now I see that I have log and a subtraction. So remembering those rules of combining, when I combine them, that subtraction becomes division. Like I could write the left-hand side as log base 3 of 4x squared minus 4 divided by x plus 1 is equal to 0. So I use that rule of combining and expanding where that subtraction became division. Now I'll write it in log form. So we have 4x squared minus 4 over x plus 1 is equal to 3 to the 0 power. Okay, base moves over, that moves up. Remember, I'm trying to solve for x. So I'm just going to cross multiply. Remember, 3 to the 0 is equal to 1, right? So I multiply x plus 1 to the other side. I have 4x squared minus 4 is equal to x plus 1. And this is definitely something that's in our wheelhouse. We can do that. So I'll move stuff over to the left. Oops. I didn't subtract correctly. Can't do that. So I get 4x squared minus x minus 5 is equal to 0. And then we can use quadratic formula or try and factor. So I'm going to try and factor it for about 30 seconds. If that doesn't work, I'll try the quadratic formula. But it looks like if I went 5 and 1 with -5 and +1, looks like we can factor that. Of course, we will get the same answers if we use the quadratic formula. So x comes out to be 5/4 or -1. Last thing you have to be careful of is you can't take the log of 0 or any negative number. When you plug something into log, it has to be positive. So looking at that -1, if we plug that in for x, that's going to make that a 0. That means that that is an extraneous solution. So you have to check and make sure that you can plug that into the original function. You can't get 0 or negative for anything in the original.